In this problem, we're going to be using a heparin protocol. A protocol is just a set of directions telling us how the med should be administered. Let's take a look at the problem. The physician has ordered an initial dose for your 156-pound patient as follows: an initial bolus of 60 units per kilogram, an initial infusion of 14 units per kilogram per hour. We're to be using the protocol on the next slide, so let's take a look at what that protocol looks like. So here we have our label for heparin. This is for IV or subcutaneous use. We would end up using this label for our bolus because we could pull this into a syringe. And we also have an IV bag, 500 milliliters with 25,000 units. So this would be for our IV drip, where we have a continuous infusion. And then we have our protocol. So this is our set of directions telling us exactly what we should do. We see the initial infusion rate matching what the doctor had ordered. And then we see the various adjustments based on their APTT value. Down here at the bottom, we see something really important. We see a maximum initial rate not to exceed 1,000 units per hour. Also, a little bit cut off on our screen, we see not to bolus in certain cases. So let's go back to our actual problem, keeping in mind the initial infusion of 14 units per kilogram per hour, and that should not exceed 1,000 units per hour. So when I read through this problem, I noticed that the patient's weight is supposed to be in kilograms. So I'm going to take the patient's weight of 156 and convert that over to kilograms. So I'll take 156, divide it by 2.2 because I know there are 2.2 pounds to each kilogram, and my calculator gives me 70.9, and I'm rounding that to the nearest tenth because it's greater than 10 kilograms. So I'll use that throughout the problem. First question that I'm asked is to find the units and to find the mLs for that initial bolus. So up here in the problem, I see initial bolus of 60 units per kilogram. And so I'll start my dimensional analysis. 60 units per kilogram. I want to cancel the label of kilograms, and so I'll multiply by the weight of 70.9 kilograms, and this will allow me to cancel that label and have an answer in just units. So I go to my calculator and I do that multiplication, and I come up with 4,254 units. And that is one of the answers that I was looking for. However, I'm not done with this problem because I'm also asked to find milliliters. So I'm going to set up the next step of dimensional analysis. I know that I need to cancel units and convert it into milliliters. So I'm going to need to know the strength of the medication that I'm using. On our labels, we identified this med as the bolus med, and it has 10,000 units to a milliliter. So I'll take that back to my problem and use that in my dimensional analysis. So I have 10,000 units to each 1 ml. This allows me to cancel the label of units, and I go to my calculator and do my math, and I get 0.4254. I'm going to try to round that to the nearest hundredth because I could measure that in a 1 ml syringe. And so I have 0.43 mLs as the amount to measure for that bolus dosage. Next, I move on to the initial infusion. So in the problem, the initial infusion is the 14 units per kilogram per hour. So I start with 14 units on top, and I want labels of both kilograms and hour in the denominator. Again, I want to cancel the kilogram label, so I'll multiply by my patient's weight of 70.9 kilograms. Canceling the label of kilograms, I go to my calculator to do the math. and I get 992.6 units an hour. So that is one of the answers that I wanted because I was told to find units per hour, and at this moment I do have units per hour. Now I should always be double checking my protocol at this point to make sure I don't exceed the maximum. I also need to check my labels so that I can convert to milliliters per hour. So let's take a look. On our protocol, it says the maximum is not to exceed 1,000. So we're at 992.6. We are less than 1,000. So that part is fine. And then our med that we need, we identified the IV bag for the IV drip, and it has 25,000 units in 500 milliliters. So we'll go back to our problem. And we'll set this up. So we want units on the bottom. And we saw that there were 25,000 units, and that was in the 500 milliliter bag. So I'm able to cancel the label of units, and I go to my calculator and do my math. And when I look at my answer, I want to round this to the nearest tenth because it is an IV rate. And so my answer comes out as 19.9 milliliters per hour. And so that is the second half of what I wanted, because now I have the units per hour and the milliliters per hour. So next, I'm told that it is 6 hours later, and my client has an APTT of 43 seconds. The APTT is the activated partial thromboplastin time, and it is a blood clotting value. So if I take a look at the protocol, it'll tell me what I should do based on my patient's APTT. So we're looking for 43, which would be in this range. And it says that we should bolus by 40 units a kilogram. We should increase the rate by 2 units per kilogram per hour. So two different things, a new bolus at 40 and an increased rate. So we'll go back to our math problem. It says find the milliliters for the bolus. So we're to bolus by 40 units per kilogram. And we know the patient's weight of 70.9 kilograms. We could stop here, but we don't need to because we're only asked to find the milliliters, so we can keep going and convert to milliliters. We're going to use the same med that we previously used for the bolus, which we had found to have 10,000 units in 1 ml. So that allows me to cancel units, and I'm ready to do my math. So I'll multiply 40 times 70.9, divide by the 10,000, and I'm going to round that off to the nearest hundredth because I'll measure that with the 1 ml syringe, so I get 0.28 milliliters for that new bolus. Then I want to find my new milliliter per hour rate. When I had looked at my protocol previously, it said that I should increase the rate by, so going up by 2 units per kilogram per hour. So I look at what it was. Initially it was at 14. I'm going to increase by 2, so I'm going to start this problem at 16. And this is units per kilogram per hour. So I need to multiply by the weight of 70.9 kilograms, and that'll allow me to cancel the label of kilograms. And I could stop there, but I'm going to keep going because I want to get to milliliters. I'm going to use the same med that I've been using for my IV. That med had 500 milliliters. with 25,000 units. And so I go to do my math. Units is canceled at this point. I multiply the whole way across the top, so 16 times 70.9 times 500, and then I'll divide by the 25,000. I want to round my answer to the nearest tenth because it is an IV rate, so I get 22.7 milliliters per hour. When I compare that to what I had figured out previously, I do see the increase, so we went from 19.9 up to 22.7. Once I had their APTT level and I looked at my protocol, I no longer had to consider a maximum because their blood tests revealed that they needed more of the heparin. And so that's why I did not have to do the second part in 2 steps. I could go directly to the milliliter per hour rate.